This screencast shows how to use the Mathematica notebook for the Special Relativity Computer Simulations Lab. To get started, go to Moodle and download the Special Relativity Simulator notebook, and then open it up, click on Evaluation, and Evaluate Notebook. And that will bring up the Special Relativity Simulator. First thing you need to do once you've opened this up is click on Initialize, and that brings up a dialog. Then click on Finish. Okay, you only have to do that once per session, but you do need to make sure that you do it before opening a file or anything else. Okay, so the idea with the Special Relativity Simulator, I should mention this is based on a previous program that I used to use called Spacetime by E.F. Taylor, and I rewrote it in Mathematica with some help from a former student, Kevin Little. The basic idea here is that the horizontal direction is like space. So these are distances here, or positions along a one-dimensional line. This direction is not a spatial direction. This is just something that spreads out things that are going at different velocities. So the farther you are away in this direction, the faster you're moving to the right, and the farther you are in this direction, the faster you are moving to the left. We have three kinds of objects that we can put on our little one-dimensional highway here. And so those, click on Create, so we can make a box or a clock or a flash. Let's make a box. This brings up a little dialog. This, by the way, is 0. It's 1.11 something times 10 to the minus some number, but very close to 0. So let's suppose we want to make a box going 0.95 times the speed of light. All speeds here are just written as numbers between -1 and 1. So 0.95 means 0.95 c. In this lab, you can actually drop the c's and drop the units on everything, but only for this lab. Times in this lab you can assume to be either in like minutes or hours or days or years, and then distances would be the corresponding thing that goes along with them, so like light minutes or light years or whatever it is. Okay, so click Continue. And we've made a box here, and this box, as we move time along, is moving to the right. Let's create another rectangular box. Make this one going to the left. And let's make one more box. In fact, we can create boxes and other things by going over here and doing Shift-click. Just another way to get to the same thing. Let's make this one at rest. Okay, now as we move time forward, we'll see that this one is at rest in our reference frame. This one's moving to the right, and this one is moving to the left. You'll notice that the faster these boxes are moving, the more length contracted they are. So this is length contracted compared to our box and our reference frame. You also notice when you hover over these things, you get some information about them. So this says what its current position is and how fast it's going compared to the current frame. So that's the case for all of these. Okay, what else? Let's create a clock. We'll create one that's moving to the right at, say, 0.8. And we can specify the velocity with respect to the lab frame or the current frame. Those are the same right now, so that won't make a difference. And we can also say if we want it to be at a certain position at a certain initial time. Okay, let's put time back to 0. And let's create one more clock going to the left this time. Okay, so here's our left moving clock and the right moving clock. And t is 0 in the lab frame, which is our rest frame right now. The line here is always us, basically, okay? And here we have a clock that's moving to the right. And at the origin, a clock created at the origin at r t equals 0 is also going to say t equals 0. This is the time when all of the reference frames moving to the right and all of the frames moving to the left would agree with each other, and everybody says it's equal to 0. If we move time forward, you see that our clocks are getting out of sync with each other. So our clock says it's t is equal to 1.7, say, minutes or hours or years, and this clock that from our frame that we're looking at, if you're standing here looking at this clock, it says it's 1.02, so it looks to us like it's keeping time, like it's running slowly. Okay, what else can we do? At some point you're going to want to see when things pass each other. Maybe I should make something else that can get passed here. So let's say that I make a right moving box that at t equals 0 is at some negative position. Okay, so there, this is a right moving box. And if I do Alt click here, on a Mac it's Command click, then I can, this puts a line on the center of each of them, and this will help us see when they're overlapping with each other, which sometimes you need to do. To actually see if they're overlapping, you can hover over them and see what their positions are, and see if they're the same as each other or not. So now the positions are different than each other, but sometimes we're going to want to know the precise instant in time when the positions are matching each other. If you need to step time forward in small steps, well, you can change the minimum time. That's the smallest time that you can go to. If you want to go to negative times, you can change the maximum time, and then the step size you can change too. So now if I click the plus sign, you see it's going forward in tiny steps, 0.001 increments. Okay, if you go to a large time and things start to go off the screen, you see you get arrows here telling you that things have gone off the screen. You can go chase them by shifting to the right by large steps or small steps. What else can you do? You can jump to somebody else's rest frame. So suppose that I want to go to this box's rest frame. So I'll go to View, Jump to Object, and specify which object it is I want to go to. This is object number 1, so let's go to that guy. Okay, now I'm in this guy's rest frame. The dashed line is the lab frame, which would now, compared to me, have things moving to the left. So now you see things are moving to the left. But because I'm in this is my rest frame now, I'm just sitting here. And this time is always in my current rest frame, okay, what time it says. Oh, one final thing, you can create flashes. So those are flashes of light, and those are going either to the left or to the right. And there it is. Okay, so that's in the lane that's going. These are, if you want to think about these as being different lanes, this is the velocity equal to the speed of light lane. You can shift the plot region, but you can also do that with these arrows. You can delete an object if you have an object that you don't want. So let's delete a clock. That should make it disappear. That's basically all of the controls. When you're done doing a simulation, you should save it. So if you click on Save, it'll prompt you to create a file. So say exercise A or something. And it's going to be a text file, .txt. So you save that and it'll get saved somewhere. And then you could start a new one. Say go to new. Oh, we do want to do a new simulation. Okay, so now it's gone. And then if you want to open one later, you can, let's do that. You can do that and we can load it in. And if all goes well, it will be here. Uh-oh, it's having to think. Okay, well, while it's thinking, it's thinking for a long time. Yikes. Whew. Okay, there it is. Okay, see if there's anything else I need to say. Oh, if you're going to save files, I would strongly recommend saving things, well, so take this notebook and first put it on your desktop if you're doing this in the computer lab. Don't do this over the network because that can lead to issues sometimes. Also, if you have these text files, the ones that you save, then first of all, if you want to open them, don't just go to the text file and double click on it. Okay, that'll just show you gobbledygook that's inside the text file. You have to run the special relativity simulator and then go to File, Open, and then browse to the file and open it that way. Okay. Also, if you need to send yourself one of these text files or save it somehow, I strongly recommend against emailing it to yourself, because your email client might actually delete the file for you. It might look like it sent it, but then it's a 0 kilobyte file that is empty or something. What you should do instead is upload it to Google Drive or something like that. Finally, if you're using one of the department's computers, when you click on this notebook, it might not open it with Mathematica. It might use the Mathematica CDF player, which won't work. So if it's doing that, then try to make sure that you're opening it up with regular Mathematica instead. Okay, just pay attention to what the lab description is saying to do. At some places it says to take some screenshots, so take screenshots and save those, and then you can paste them into your Word document that you're going to have for your lab report. All right, let me know if you have any questions once you get started.